Hey everyone! Today we are breaking down a really important concept for anyone building serious AI systems. It's called the Model Context Protocol, or MCP. And trust me, if you're working with LLMs, this is a standard you're going to want to get your head around.
Okay, so here's our game plan. First, we'll dig into the messy problem that MCP was actually designed to fix. Then we'll introduce the solution itself and see how it works under the hood. After that, we'll talk about the real-world impact on your system's architecture, and we'll finish up with the key takeaways you need to know.
All right, first things first. To really get why a standard like MCP is such a big deal, we have to start with the problem it's solving. And that problem is the chaos that comes from all these custom connections in today's AI systems.
So let's just start with the most basic question, right? You've got this amazing LLM. It's like a brain in a jar. It can reason, it can plan. But how do you get it to actually do anything? How do you connect it to the real world through tools and APIs?
Well, the reality for a lot of developers is a mess. It's this tangled web of custom glue code. For every single new tool you want to add, or every time you want to swap out one model for another, you're back to the drawing board, writing this brittle custom code. It's a total nightmare to maintain, and it absolutely does not scale.
Okay, so how do we fix this? How do we untangle that web? Well, this is exactly where the Model Context Protocol, or MCP, comes into the picture. Let's take a look at the much cleaner solution it offers.
So what is MCP, really? At its heart, it's simply a standard interface. The best way to think about it is like a universal adapter, you know? Like a USB-C for AI. It's a common language that lets any LLM talk to any external tool or database or memory system without needing to build a custom connector every single time. And here's the really brilliant part. The core idea is to separate the reasoning, that's the LLM's job, from the execution, which is what the tools do. It's a classic software engineering principle, right? Separation of concerns. And applying it here creates a much more robust and flexible architecture.
Okay, that sounds great in theory, but what does it actually look like in practice? Let's visualize the architecture and trace how the information actually flows through the system.
All right, so at the very top of our stack, we have the large language model. This is our brain. It figures out what needs to be done. But, and this is the key architectural decision, the LLM itself doesn't talk directly to any of the external tools.
Instead, it packages up its intent into a standardized request. It might look like a simple JSON object that says, hey, I need to call this tool with these arguments, and it sends that request to something called an MCP client.
Now, this client's only job is to communicate with an MCP server. You can think of this server as the grand central station for all your tools. It's the gatekeeper. It knows what tools are available, how to call them, how to pass context. It handles all of that logic.
And yeah, this server is the one that actually gets its hands dirty. It's a component that's plugged into all your APIs, your databases, your RAG systems, your agent's memory, whatever you've got. All that complexity is contained right here, behind this standard interface. The LLM never has to worry about the messy details. So, if you boil it all down, it's a really simple four-step dance. 1, the server exposes its tools saying, here's what I can do. 2, the LLM reasons about which tool it needs. 3, the client invokes that tool using the standard protocol, no custom code necessary. And 4, the results are returned back to the model as clean, structured data. It's a beautiful, predictable loop.
Okay, so we get the mechanics, but what's the real-world impact here? Let's talk about the architectural benefits and why this actually matters so much when you're building these systems.
And the impact is huge. Seriously. First, you completely decouple your models from your tools. This means you can swap out an LLM, say from GPT-4 to Claude or Gemini, without having to rewrite a single line of your tool integration code. Second, your tools become instantly reusable. You build a tool once, expose it via an MCP server, and now any agent or model you build can use it. And all of this leads to the big payoff: cleaner, more scalable, and way more maintainable architecture.
All right, let's bring it all home. If you're walking into a meeting or, a technical interview, what are the absolute key points you need to remember about MCP?
Okay, 3 crucial things. Remember these. Number 1, MCP is a standard. It's a set of rules, a protocol, not a specific product you buy. Think of it like HTTP for AI tools. 2, its whole job is to separate the brain, the LLM's reasoning, from the hands, the tool's execution. And 3, the direct benefit of doing that is you get reusable tools and a much cleaner system design. Simple as that.
And that really leaves us with a pretty exciting forward-looking question. Now that a universal standard like this exists, making it so much easier to build robust, complex systems, what new kinds of powerful and reliable AI agents is this going to unlock? What happens next? It's definitely something to think about.